Good morning, team, and welcome to week 3 of eSchool. I'm going to make another one of these quick videos to show you what we're going to be doing this week, what your expectations are, and kind of a walkthrough of each of the modules this week. All right. This should be your Google Classroom homepage, or this would be mine. You will have a pure physics one, and it should say you have 2 modules. Notice that there's 2 this week instead of 3. 2 modules due at noon on Friday. Okay. Now, week 3, module 1, is a little bit longer. It has 3 experiments in it. And during this module, you're only going to have a digital worksheet that you need to turn in, as well as a mastery check. For week 3, module 2, it's going to be a little bit shorter, but there's going to be an Edulastic formative at the end. Okay, so again, 4 things you need to be turned in by Friday at noon. Week 3, module 1, week 3, module 2, digital worksheet, as well as the mastery check for module 1, and the formative for module 2. All right, so let's dive in here. All right, you click on your particular classroom, and it'll bring you to the stream. Okay, now in the stream is where I'm going to make announcements, post assignments. All right, you'll notice that the 2 assignments are posted here. We can also go to classwork, and you'll notice that there's a new topic created called G.5, gravitational force, distance, and mass. This week we're going to be working on the relationship between the gravitational force and its dependence on the distance between the 2 objects and the mass of the 2 objects, okay? So let's get started on week 3, module 1, which is what you all should be working on today. All right, you'll notice that you are assigned a digital worksheet, but no slides, okay? For this week, we are only doing digital worksheet. So let's go ahead and click on this, and you'll be redirected to your page, all right? Now you are able to edit this, seeing as this is your copy, and turn it in via Google Classroom like we've done in the past. All right. Quickly walking through this module. All right. Remember I mentioned it's pretty long. Okay, so make sure you pay close attention to this video and any video that's linked into the document itself. So G.5, gravitational force, distance, and mass. Our objectives is by the end of this unit, students will be able to determine the relationship between gravitational forces on objects, determine how the mass of 1 and 2 objects affect gravitational force, and understand how distance affects the gravitational force. All right? You've got a few vocab terms that I would like you all to internalize. After that, you're going to go into your do now. Okay? Remember, you are able to edit this. All right? If you would like to use text to speech, that is available here for any of those of you who would think that is beneficial. The forces that act between Earth and asteroids are, type your answer here. Anything that is highlighted is a sentence stem for your guys' benefit, okay? There are 3 questions for the mastery check, okay? Once you have completed the do now, you can move on. There's no answer key because these are your initial ideas, all right? There are no wrong answers here. So right now, we are just jotting down ideas, what you guys think at this point, all right? We're going to revise those ideas later on in this module. As you move through the do now, at the end, you're going to notice that you get your first direct instruction, all right? These directions are how to do today's module. Really important that you click on this link and watch the full video, okay, before you move on to experiment 1, okay? Once we get started with experiment 1, we're going to be testing how does the gravitational force on 2 objects compare, all right? To do this, we're going to be utilizing a Phet Sim like we've done in class. The link to the Phet Sim is linked here, so it says go to this link. Let's go ahead and go to that. And you'll be drawn to this Phet Sim page like this, okay? We're going to click on this play with simulations, and you should get an interactive Phet Sim that looks something like this. Now, what I want you to do is I want you to adjust the masses. So say you put the mass up to 104, how does that change the force of M1 on M2 versus M2 on M1? Pay close attention to these numbers, guys. You'll be interested in these numbers at the end. All right, do they match? Are they different? That's what you're going to compare in this first question, okay? You can drag the characters around like such. You can adjust the mass, but make sure whatever you do, you only adjust one variable at a time. So if I want to see how the mass affects it, I would just adjust the mass, but keep the distance constant, okay? If I wanted to test the distance, I would keep the mass constant and adjust the distance, okay? Once again, make sure you pay attention to these last 6 numbers in this number. It's a very small number, so these are the integers you're interested in. Okay? All right, let's go back to our digital worksheet. Once you do that, you're going to answer a question about how the 2 forces compare. And from there, you're going to move to step 2. All right. So imagine that M1 and M2 exist in space very far away from any other objects. By saying very far away, they are stating that there is no gravitational force due to any other objects, okay? So you're going to insert a force diagram here. Just so you guys recall, to insert a diagram or to draw, you're going to go up to Insert, Drawing, New, and then in this environment, you are able to draw using the tools up here, okay? Select a line, you can draw arrows, you can draw boxes, shapes, arrows, callouts, equations, anything you want to add there. Once you are done, you're going to put save and close, and that'll input it into here. You can move it around so that it ends up right here, okay? So force diagram for M1 and force diagram for M2. Please pay close attention to the direction of your arrows and the length of your arrows, as those are both very important here, all right? In step 3, you're asked to look back at your initial ideas in the do now and then adjust them here, okay? So type your answer there before moving to step 4. In step 4, you're going to be asked to read a key idea. Your key idea is located here. Once again, if you desire speech to text, it is here where you can watch the video above to access it, okay? You're going to answer this question that relates very closely to this key idea about force pairs, okay? Think back to what we talked about with Newton's third law way back in class, okay? That every action has an equal and opposite reaction. Every force has an equal and opposite force when pushed. Remember, it's a push and a pull force. Okay, then after that, you can go ahead and check your answers, Once you get done with this, you're done with experiment 1. You click on check answers, and that's going to open up a new tab with the answer key, all right? Only check your answers after you've completed all of this experiment, okay? But make sure you do check your answers so that you know you're on the right path. In experiment 2, we're testing how does the mass of an object affect the gravitational force. All right, in step 1, they give you a bunch of data. All right, they give you data about a bunch of asteroids. All right, they tell you the mass, the distance from the Earth, and the gravitational force. All right, so on the image to the right in step 2, you're going to draw the force diagrams, okay? Notice that this first one is UQ114. So you can look up here and see that this one is this guy right here. All right. The second one is 2014 VP, which is the top one up here. All right. So pay close attention to that as you're drawing your force diagram. To draw your force diagram, everyone, you can select this picture, click Edit, and that's going to bring you to the drawing environment where you then can directly edit onto this picture. So say I wanted to draw an arrow. All right, let's do an arrow that way. Let's draw it like so. All right, now I've drawn a force diagram on Earth. Okay. Once I save and close, that'll immediately edit this picture here, and you are done. Okay. Moving on to step 3. All right, you're now going to test the relationship between the mass and force. You are going to only look at asteroids that have the same average distance from the Earth. Guys, that's very important. We are only looking at asteroids that have the same average distance. So we are not looking at 2014 VP and 2005 VN because they are different distances from the Earth. Okay, only work with asteroids that are either 8 or 17 away. Okay. So again, please do not look at any that are different distances. That will skew the data. Okay, after you answer this question about why that's important, you're going to move down here, all right, where you're going to graph the data. All right, so the data table from step 1 provides the most data points for the distance 17 times 10 to the 8th meters from the Earth. All right, there are 3. Using only data at this distance, again guys, only data at that 17 times 10 to the 8th meters, graph the mass of each asteroid and the gravitational force between the Earth and each asteroid. So graph the mass, all right, as well as the gravitational force. Mass is going to be down here, gravitational force up here. Okay? Cool. Once you're done graphing that, you read this key idea here, answer the questions before moving on to step 6, which is make a claim about the relationship between the strength, where you claim here saying the mass of the one object is blank, blank to the finish the statement, okay? After that, you're going to do your evidence that you gathered throughout your experiment that backs up your claim. All right, once you've finished step 6, you're ready to check your answers before moving on to experiment 3. In experiment 3, how does the distance affect gravitational force? Look at the data table shown to the right. All right. This data table is going to be used to answer the following questions. Notice you've got another list of asteroids, their masses. All right. Notice they're all the same mass now, but they're different distances. We're now working with distance. Okay. So how does the distance away from the Earth affect the gravitational force? All right. When finding the relationship in step 2, all right, what variable needs to be held constant? Okay, so in this data table, which variable had to be held constant in order to study the relationship between the distance to the Earth and the gravitational force? After that, you're going to draw another graph based on this data table, similar to the one you did up here. Following that, you're going to answer the questions on the right based on your work from step 3. All right, based on this graph, you're going to answer these questions before moving into your last little bit of claim and evidence. Okay, claim, make a claim, provide evidence. Make a claim, provide evidence. Okay. After you're done with that, go ahead and check your answers, guys. And before you move on to your mastery check, make sure you review what you've learned so far. So start at the beginning in experiment 1. Make sure your answers match. Review your answers and your claims and evidence before moving on to your mastery check. Another helpful tip is down here, the key points. You have 5 key points for this lesson. Make sure you internalize those before moving on to the mastery check, which is titled this. All right. Once you are done with this mastery check, you can then go ahead and move on to module 2. Okay. Well, guys, that is it for module 1. I'm going to post another video for module 2. Module 2 is much shorter, but very important as well, especially seeing as it has a formative at the end. Okay, you should be spending the whole period on Monday and possibly Tuesday working on this module, seeing as it is very long. All right, thanks guys, and hopefully this was helpful.